Hello, everyone, and welcome to this session in the 2022 edition of Distributed SQL Summit on YugabyteDB's architecture for scale and resilience. We have a packed agenda today and a lot of functionality demos for you. So without further ado, we quickly move on to the intro slide. This is who we are. My name is Rahul Bhatta. I am a pre-sales engineer here at Yugabyte. I collaborate with sales and account teams to provide technical coverage for the product in an attempt to be the trusted advisor for our customers and users alike. I'm fortunate to have the industry experience in verticals like solution architecture, cloud computing, sales engineering, and running heavy operations with varied organizations in the past. I'm also joined by my esteemed colleague here, Amit Chauhan. And Amit, over to you for your quick intro here, please.
Thank you, Rahul. Hello, folks. My name is Amit Chauhan. I'm a pre-sales engineer at Yugabyte. My role here is to partner with our customers and help them succeed with their database journey. I have a deep interest in distributed systems and data engineering. And before joining Yugabyte, I have worked as system architect and developed several products which dealt with petabytes of data. Back to you, Rahul.
Thanks, Amit. So in an attempt to set the context and stage for today's discussion, let me ask this. Why are the databases, seamless scale, and resilient architecture so very important for businesses today? From definition perspective, we can usefully define resilience as a company's capacity to absorb stress, recover critical functionality, and thrive in altered circumstances. In other words, be nimble for whatever is thrown your way while keeping the lights on. Some aspects become naturally unpredictable in response to situations like when security landscape changes so frequently, when more and more control of your infrastructure goes to cloud, need to have active replicas, or having a single unified data store for all types of data, be it SQL or no SQL. So essentially, business continuity drives the need for databases to be resilient, always available, scalable, persistent, and failure-proof. That said, this is what we are going to talk about today. We'll start with answering why Yugabyte, then we'll see how Yugabyte does it. And we'll quickly jump to the show and tell demos for our cloud product, the YugabyteDB, along with some of its capabilities. We'll see how the business applications never go down in situations like region or zone failure, scale up or scale out, or even during maintenances like database upgrade, maintenance, or patching. And if time permits, we'll take some quick live questions in the end. For the next couple of slides, we'll see what is the need of Yugabyte in today's marketplace and how does Yugabyte do a killer job of what it claims. This slide speaks about the ever ongoing tech stack modernization. And speaking of which, you would have seen these kind of trends regularly from vendors over the past years, right? You know what microservices are, you know how the shift to anywhere data access happens, how about growing edge and faster development, etc. And as a result of these different demands that have come down from customers and organizations, the IT stack continues to evolve and get better. You've seen the application modernization in containers and K8s. We've seen infrastructure modernization in cloud and virtualization, but something's missing. What about data layer? So data layer forms the core foundation of any application and is essential as all businesses become more and more data-centric and data-reliant. So the question now becomes, what's next for the data layer? Is it not the time for data layer modernization? Let's see in the next slide. Database solutions have evolved for data layer as the industry went about it. It's a space with lots of options, and while there have been some nice advances in recent years, if you really dig deep into it, it's been a story of 2 steps forward and 1 step back. What I really mean by that is all database innovations came up with their own set of trade-offs and compromises. Legacy relation solutions have been proven themselves for decades and decades now. They deliver consistency, ACID, powerful database indexes, and familiar relational models. But those benefits come at a cost. Some of their struggles include scale out, replication, and geo-distribution, which are basically detrimental to your modernization efforts. NoSQL's databases similarly were born, and they delivered scalability, geo-distribution, and native replication. However, you have to give up a lot. You're now forced to compromise on core database capabilities, as in no consistency or ACID, next to none indexing, and a well-known relational database model is not there to be seen. And more recently, major cloud providers have tried to bridge those 2 worlds into a cloud model, but trade-offs still exist. You'll have to trade off the many benefits of an open source solution and will be logged into a single cloud. And then the architecture of those solutions still limit the scale and geo distribution that businesses need today. So the bottom line is these trade-offs cost your business with lower productivity of personnel, higher cost of development and maintenance, higher risks, and ultimately settling down for less than what the businesses need and necessitate. This brings us to our question from 2 slides back: why YugabyteDB's distributed architecture? And the answer lies in our mission to eliminate your data layer trade-offs. And how do we do that? First and foremost, at Yugabyte, we follow the way that doesn't enforce these tough trade-offs and compromises. First, YugabyteDB takes the best of relational databases, the SQL world, and delivers data consistency with asset properties, leverages familiar interfaces like Postgres, and incorporates native security. Second, YugabyteDB includes all the goodness that comes from the non-relational or NoSQL databases that are key to any cloud-native application. And this includes resiliency, horizontal scalability, and geo-distribution. And finally, YugabyteDB includes the key capabilities critical to any business looking to the future. Increasingly, there is a strong desire for open source and the benefits it brings around extensibility, transparency, security, and lower cost. And the result is a uniquely positioned database that avoids the common trade-offs that have plagued us in the past. In the center of all these worlds is YugabyteDB, the 100% open source database, 100% open source distributed SQL database for any cloud. And then these are the 4 specific capabilities that are important to highlight and always top of the mind. First, by using the query layer of Postgres, we are able to offer more advanced features than any other SQL database solution out there in the market. Native resiliency and availability of Yugabyte enables you to be able to survive multiple failures with automatic healing, re-replication, and enjoy zero downtime during the upgrades and security patching with simple built-in capabilities. With rapid horizontal scalability of Yugabyte, you can easily and linearly scale queries, storage, and connections by adding nodes during peak traffic and then scale down in the reverse order as required and demanded by the business. With built-in comprehensive and geo-distribution capabilities, we distribute data across zones, regions, or clouds with full asset consistency. And this is the pictorial representation of our database architecture. At the heart of the database, the orange box, we have 2-layered architecture. At the bottom is a distributed transactional storage layer, and this layer is inspired by Google Spanner, which is built for horizontal scalability and geo-distributed applications. The storage layer actually is responsible for transactions, sharding, replication, and persistence. Along with inspirations from Spanner, we took proven technologies like Raft consensus that we further enhanced and optimized to build an enterprise-class 100% uptime distributed SQL database. Above that is our pluggable and extensible query layer. We offer a Postgres-compatible query layer like Amazon Aurora, which can support a rich set of data functionality and support the broadest range of use cases and features possible. Currently, we support 2 flavors of distributed SQL APIs, but have the flexibility to easily expand in the future. And then towards the bottom, you can see that the YugabyteDB has ability to run anywhere on any cloud, from private cloud, public cloud, hybrid multi-cloud environments, and virtual machines to containers to Kubernetes. And at this time, I'd like to hand it over to Amit as we transition from architecture diagram to the database internal deep dives. Over to you, Amit.
Hi, folks. We'll do a bit of deep dive into database internals to explain how Yugabyte achieves scaling and resilience. So let's get started with the scaling. In order to achieve scaling, the most critical property is that the database should be able to distribute the data of a single table into multiple nodes. Let's take a very simple example. We have 3 nodes in the cluster spread across 3 failure zones. We take a table and split the rows into groups. Each group is referred to as a tablet. This sharding is transparent to the user and is performed automatically by the database. So now we have a table broken down into smaller row groups, and we are able to spread these row groups across multiple nodes. This sharding happens automatically. Our load balancer makes sure that these row groups are evenly distributed across the nodes, and there is no skew. In this example, we have only 6 tables represented by different colors and evenly distributed across these 3 nodes. In real deployments, there will be many tablets per node, 10, 20, 30. It really depends on the size of your table. And each row belongs uniquely to one tablet. So let's see how horizontal scalability works. We have a setup with 3 nodes containing 6 tablets. Now we want to scale our cluster to 9 nodes. When you add new nodes, Yugabyte will automatically distribute the tablets to new nodes. If you don't have enough tablets, Yugabyte will dynamically split the existing tablets and distribute them. So, okay, now we have looked at how horizontal scaling works. Let's discuss how we achieve high availability and resilience. So we will always have situations where software upgrades are needed, or some node has failed, or even some zone has failed, right? So let's see how Yugabyte will handle these sort of situations. If we have a single copy of data, you won't be able to survive a failure of a node, right? So we replicate the data across multiple nodes in such a way that in spite of some node failures, cluster can serve the data with no data loss and with absolute consistency. To achieve this, we use Raft consensus algorithm. And in this example, a tablet is replicated across 3 different nodes. Raft algorithm makes one of the nodes as a leader and others as followers. The leader election can and will change dynamically. So how replication happens in a 3-node cluster? In this example, we have tablets spread across these 3 nodes. Solid outlines represent the tablet leaders and dotted ones are followers. And what we will see in node 2, if it goes down, it has a yellow and pink tablet leaders, and it has a followers on node 1 and 3. Now read and writes for a particular row will always go to the tablet leader with Raft, which Raft has elected for you. So when reading the data, the tablet leader will serve it up right away. For writes, it will replicate to all the followers and wait for the confirmation from the majority of the nodes before committing this data. You will note that Yugabyte will ensure that these tablet leaders are all uniformly spread across different nodes. So we can utilize all the nodes in the cluster uniformly and provide the best throughput to the users. Now, when we want to horizontally scale this cluster, we'll add 6 more nodes. Yugabyte will automatically redistribute the tablets to newly added nodes. Yugabyte ensures that everything is evenly distributed and all the nodes are fully utilized and provide increased throughput to the users. So now let's discuss how Yugabyte tolerates the node outages. In this diagram, I'm showing that node 4 has failed. On node 4, we have a yellow tablet leader present. Raft will elect a new leader in 3 seconds from a different zone for the yellow tablet. For the followed tablets present on this failed node, there won't be any impact since purple leader is present on a different node and that takes all the reads and writes. There won't be any data loss since the yellow tablet leader dies and won't be replicating any data. Within 3 seconds, a new leader will be elected and it will start taking the writes. So now let's say our node 4 has been down for 15 minutes and it's not coming back anytime soon. So what Yugabyte will do is that it will automatically create the additional tablets on different nodes for yellow and purple tablets. This is all automated and you don't need to do anything. Once node 4 comes back, Yugabyte will again go and transfer the tablets to node 4. So this ensures that the tablets are always well balanced. And by the way, this 15-minute is configurable. If you want a lower number or a higher number, you are free to do that. I have given an example in an earlier slide with respect to the single node, but the same thing applies to your entire zone failing, or if a region is in your multi-region cluster fails. So your application will have a 0 impact. This is a great example demonstrating how Yugabyte handled a complete regional outage. So due to severe snowstorm, this retailer lost the entire US South region. Within 3 seconds, tablet leaders got shifted to other regions and there was no customer impact. No data was lost. Yugabyte guarantees the RPO of 0 and RTO of 3 seconds. We are built to handle these kind of situations, and our customers can attest to this. So we were born as a cloud native app, but we are designed to run both in cloud and on-prem. Here are some of common topologies our customers use. So you can have a single region, multiple zone setup. This will tolerate the entire zone failure. Second is like single cloud, multiple region. If you have a requirement that the database survives entire regional failure, you can stretch your cluster across multiple regions. Third, you want to run a database in multiple clouds. You can do this with Yugabyte. It's not very common use case, but we do support it. We also offer async replication with X-cluster setup. This is very unique offering by Yugabyte. You can have two clusters running separately in different regions and can have a bidirectional or unidirectional async replication setup between the two. So let's say cluster 1 fails, and app 1 can fail over to cluster 2 and keep serving the customers. I would now like to touch briefly on our Yugabyte Smart Drive. So Smart Driver is a cluster and topology aware, and we will be adding shard awareness to it very soon as well. We have drivers available for all major languages: Java, Python, Go, Node.js, you name it. We discussed the internals of our Gigabyte achieves resilience and scaling. Now we are going to demonstrate these features on Yugabyte Managed platform with a homegrown app. With this, I will pass the baton to Rahul.
All right, thanks, Amit. So now I'm going to showcase the UI console of our flagship cloud DPaaS product, the YugabyteDB Managed, where you bring in the apps and we handle the database. So once you log on to the Yugabyte Managed console, we have the database clusters listed out here with their collective infrastructure information along with their database versions and regions they are in. You see one of the clusters is in pause mode in order to reduce the idling expenses, while the other one is active and has fault tolerance set to availability zone level. You can use the left pane to set up alerts, network access, and admin configs. Let me quickly peek in the network access and see we have the IP allow list and VPC information logged in there. From here, we go into the active cluster, the Polite Wombat, and this is its overview page. It's hosted in AWS in US East 2 region with 3 nodes, 48 cores, and encryption enabled. Bottom of the page shows its metrics like ops per second, latency, CPU, etc. The tables tab has the details of the database tables. You go to the nodes tab to see the node names, their region, zone, memory, SSDs size, and other read-write operations per second. In performance tab, we can also choose to select the custom metric views like this to actually display the details we want. And then this is how you see the live queries running on the database along with the slow queries. Recently added Performance Advisor tab allows you to run scans periodically and report tuning recommendations. Activity tab lists the infra maintenances like node add drop, database upgrade, etc., along with their start and end times. And then the settings tab has some of the additional config information on a single page. At this point, let me introduce our in-house workload simulator app. That's how the screen looks like. The bottom left shows how the cluster is laid out in the cloud, and the top half shows the latency and throughput numbers against the database. So I have worked my simulator app running against my Polite Wombat cluster for all the demos today. Here I show you how to run the simulation read workload on 3 tables with a TPS of 1024 threads in total. You see a fresh workload starts and its latency plus throughput numbers are starting to warm up. And I also want to show you it's still running. And here, there are certain instructions available on 3 ways to connect to the database here. The bottom one is how your application will connect. You download the certs, choose your query flavor in YSQL or SQL, and here is the connect string. If you want to connect your favorite client shell from your favorite operating system, you download the script, download the certs again, choose the query layer, and use the SQL SH like this to connect to the database. And finally, you can launch a cloud shell, provide details as listed here to get on screen like this to get a Yugabyte prompt from the cloud shell. And that said, we are almost ready for our first demo here, which is to simulate the loss of one zone and see its zero impact on the running applications against the database. So we know this app screen, and I have added a small wall clock at the bottom left to exhibit the fast forward as part of this demo in a cleaner way. So remember, I had started a workload short while ago, and the top section shows the application is chugging along nicely. One last confirmation on the Cloud Console UI before we disrupt our dear polite wombat cluster for this demo. Okay, everything looks good. Now we go ahead, we go back to the application and synthetically drop a node from the database. We go to the workload and we go down to stop the node, and here you go. One of the database nodes has been stopped in an attempt to create a synthetic node loss. And I leave it here to see that there are some spikes and dips seen, but at no point the graphs fall down dead to the bottom. What I also expect to see here is the cluster topology change, reflecting a node loss in a short while. All right. And here you go. We have two nodes left across the two zones. And since this is an RF3 cluster, we still have two nodes sustaining the application load, and the application on its part just keeps running with similar latency and throughput numbers. Here you see one of the nodes is marked red and is down, but no red flags visible with metrics, latencies, CPU, or other resources. Okay. Now, to reverse down the change, I'll go ahead and start the node that I had killed earlier. And here we also see how seamlessly the cluster and the database resumes. Actually, it's resuming now. It's resuming its operations on the node that was once downed. So I'll let it run. This node down and up scenario also simulates what we can, or how we can undertake the planned maintenances manually on the cluster. While the magic is happening in the background, let's see, at any time the node can come back. Running. The magic is happening in the background. The node is being added, and here you go. The node has joined back as reflected in the topology. Here, the numbers are still looking good on the top side, or the top half of the screen here. Barring some spikes and dips, the application isn't under stress at all. I just want to spend some time here. The things are looking good. It's running. The Cloud Console also reflects the node is brought back. Everything is hunky-dory. Looks like we are back in business. And with that, I hand it over to Amit for the next set of demos. Over to you, Amit.
Let's jump into the demo. We are going to show you horizontal scaling of the database, and we have this app running with 3 nodes spread across 3 availability zones. And if I go to my UI, I will show you there are 3 nodes. They're right now taking traffic from the app. Let's go hit actions. Let's add 3 more nodes and do a confirm and save changes. Now you will see the message update has started. And we come back to our app. What will happen here is that 3 new nodes will be provisioned, and then we will be installing software on that. So let's look at the nodes. Now you can see that the 3 nodes have already been provisioned, and Yugabyte behind the scene, it's installing the software on each of these nodes. And once that is done, Yugabyte is going to go rebalance the tablets to the newer nodes. So we are fast forwarding through our latency and throughput charts in here. And we will soon see some spikes here and there with the latency and with the throughput going on. So we'll let it run for a few more seconds, and at any second now, like we will be seeing these addition nodes. So now you've seen the focus on our topology diagram that the total cluster has become 6 nodes, and 3 new nodes have been successfully added. Going to our UI, like you will see that we have 6 nodes, 96 vCPUs, and 384 GB total memory for this cluster. If you go to nodes, you will see all the nodes are looking healthy. The files have started spreading across these nodes, and looking at our application UI, all the latency and throughput is very unique. So let's jump into our next demo. So here we have this version 2.12.9 of this database, and we are going to upgrade it to 2.14 version. And I have already started the app in the background. Let's go and get started on this UI. You will see that 3 nodes are taking all reads and writes operation equally distributed. Let's go to our admin console and hit upgrade to 2.14. Let's do a confirm, and we should see a message pop up that upgrade has started. And I will refresh my page just to show you the message that it's under maintenance. And right now, our UI is running very smoothly. Like there, you don't see anything on the latency or throughput chart. But this is going to change as we'll go node by node. Like now, this particular node has started installing the new software in here. So you will see that it has turned red. But going back to application, it's still running smooth. You will see occasional dips on throughput and occasional spikes on the latency, but that application is 100% available. Again, going to the UI, we see that another node has gone under maintenance of the upgrade process, and still the charts are looking very clean. Some minor blips again from time to time. Let's see what happens after this refresh. So this is one node which is like not taking any read writes now. It's undergoing the upgrade process, and we'll let it run for a few seconds, and maybe we can then fast forward this to further down the line. It typically takes 20-30 minutes to upgrade the typical cluster, and you can do it offline. You don't have to do it like online. So now I saw some big spike on the latency, and very soon we should see that our cluster has upgraded to 2.14.1. All my nodes are looking very healthy. They are equally taking the reads and writes. If you look at the rightmost column in here, and my app is looking very, very, very healthy in here. There were some spikes. So now I would like to leave you with this slide on the screen highlighting the standout features of YugabyteDB. Rahul and I would like to thank you for joining our presentation. We hope you enjoyed it, and we are ready to take any questions now.